Hello everyone, how are you? Hope all are doing fine. Today will be the last lecture or the last part in the heat transfer material. It is a forced convection. What is the meaning of forced convection? That we force the air, we force the liquid to flow through the pipe or to flow through the atmosphere. Okay, everything will be explained, but we have two main equations that we use it. We know that Q is the heat transfer rate equal H area, TW is the T for the wall, and TB is the temperature through the cross sectional. We know that the temperature changes through the pipe or through the flow. Okay, but here H is not the coefficient that we use to calculate. H here is the fluid properties. Okay, this fluid properties, it's too many parts we will talk about later and how to calculate it. And the other equation that Q equal M, which is the mass flow rate, Cp and delta T, everything will be calculated. We have to know that there is too many types of the flow. We give example that when we have a fan, we accelerate the rate for the flow. So there here will be a temperature for the velocity through the wall different from this length, from that length, from that length, or if it goes through a hot surface. So we have two types for the forced convection. If we make it internal, that will be through a cylinder, or we will have it external. We'll explain external. What is the meaning of external? That we force the air or the liquid through the atmosphere. For example, if we here in this house, we make a fan for the exhaust. The exhaust is go and make a fluid or velocity to the atmosphere, to the air, right? Or here with the fans, we make fan, we accelerate the air flow through what? Through the atmosphere. And also here for the pressure, we make a pressure, or we make a development for the flow behavior through what? Through the atmosphere. Okay, the second type is the internal, that we will study here, that we flow the object inside a pipe. That this is, for example, this is a pipe. We make the flow, we push the flow with a fan, whatever, like a pump, through a pipe to go through the other side. So we will have here velocity that the flow will go, and the velocity we here said it is the average velocity. It will be given, it is the average velocity at the cross-sectional, because the velocity here it not be the same here, because here is called what? Wall velocity. For example, here it will be 0, it will differ from here and there. So the given velocity it will be the average velocity, which really mean the mean velocity. Okay, that's what we call that the mean mass flow rate, which calculated here, the mass flow rate. This is the average velocity, and this is the area for the part, and we give it, and this is here the rho, which is a density for the flow. Okay, so we have many types of temperature, which is what we have a temperature here and we have a temperature there, and maybe sometimes he give you the temperature for the atmosphere. Okay, so there is another part for, it's called the temperature, is what we will know here. So now the bulk mean fluid temperature is the TB1 plus TP2 divided by 2. What is the bulk mean fluid temperature? It is the temperature TP1 and TP2. Okay, sometimes TP2 it is required as the problem number 1 in the sheet. Sometimes, look here, TB1 is required, or TB2 whatever is required. So in this case we take the TB1 equal TB, the bulk, till we get the Q, and then we will show later how to calculate it. Before we start, there is two types of the duct. For the flow, in case we have a duct, there is a cylindrical duct, right? And there is a square duct. Okay? Which is better, this or that? This is better than this. Okay? For what? Because here the pressure distribution is not equal, so there will be deformation for this square duct. Therefore we usually prefer to use the cylinder duct. We go back here for the steps for the solution. First thing, we calculate the TB. If it's not given, TB2 it is required, we saw the TB1 equal TB. And then we go through the table. There is a table given to calculate the fluid properties. TB, to calculate the fluid properties, you must add 273 to change from Celsius to Kelvin. Okay? In case in the exam the table is not given, you will find in the equation these parameters given, that it is the fluid properties. This is what the dynamic viscosity, the rho is for the mass density, Cp is the specific heat capacity, PR, which called Prandtl number, is a measure for the relative thickness of the velocity and the thermal boundary layer. It's something called to the fluid. If you studied the fluid, the material fluid, something related to it. And this is the velocity of the fluid, which is be given. Okay? So from here, from the table we calculate these parameters, or we check it. If the table is not given in the exam, make sure that these parameters will be given. Okay? The third part in the steps for any equation related to the forced convection, it will be the third part is the Reynolds number. Reynolds number is the rho, and the rho is calculated from the table, and V is the velocity will be given, and D is the diameter, it is also be given, and this is for the meow, it will be given for the dynamic viscosity. Once you calculate the Reynolds number, you have to make sure whether it's smaller than 2300, so it will be laminar, and this is constant mu, which will know that it's what Nusselt number. Nu is the Nusselt number. This is a steps for the problem, how to solve it. Okay? So nu is the Nusselt number. It will be 3.66 in case if the flow is laminar. In case of the Reynolds number is bigger than 4000, therefore the flow is turbulent. And the Nusselt number will be calculated by this equation. 0.023 times Reynolds number 0.8 times PR. It is also a coefficient parameter for the fluid properties taken from the table, and N will be 0.4 in case of heating and equal 0.3 in case of cooling. Okay, and it will be given in the equation that this process are heating or cooling. So now you have the Nusselt number from this or that. We can make this equation to calculate the H. As I told you, H here is not the H that we used to. H here is another parameter which will be equal to the D and K. The last part is that we make a direct substitution for the Q. H here is calculated from Nusselt number, and area here equal by DL, and this is the temperature that we mentioned. In case, as we mentioned, that anything of the parameters is required, we take Q here, the total value, to be equal to this MCP, where M equal rho AB, and area here in this case equal pi d squared. That's all. If you have any question or anything for the concept you didn't understand, send me a private message and I will direct contact you.